Density is mass divided by volume. All right, so basically your density is how much stuff you have in you divided by how much space you take up. All right, and in general, the most used units for density are either going to be gram per milliliter or gram per centimeter cubed, okay? Because gram is gonna tell me my mass, and either milliliter, so that's talking about volume in liter, or centimeter cubed is talking about volume in centimeter cubed. All right, so these are just units of either gram per mil or gram per centimeter cubed. All right, usually we talk about something is being lighter or something is heavier, which is why it would like sink or float, right? This is lighter, so like a hot air balloon is lighter, so it will float in the air, it will rise in the air. This is not technically true, okay? What we actually mean when we say these words is that something is less or more dense, okay? So if something is less dense, it will rise or it will float, like a boat will float on water. If something is more dense, it will sink. So a really good example of that would be a beautiful picture. Okay. All right, so my beautiful picture is here for you. All right, let's say that I have a cup with 100 grams of water. All right, and I have a 10-gram block of wood and I have a 1-gram nail. And I'm going to put both the block of wood and the nail into the water. Okay, you all already know what's going to happen, obviously, but if I put this 10-gram block into the water, it doesn't matter that it's 10 grams. What matters is its density, right? This is actually going to float. Ooh, if I can draw this again. Okay, 10 grams. This is going to float on top of the water because of how dense the actual wood is. Okay, the wood itself is not, it's not that it's not heavy enough, right? Because this weighs 10 grams, but it's still going to float on top of water because it's less dense than the water. Versus the nail, right? The nail is only 1 gram, but we all know what happens if I plunk a nail into water, it's going to sink to the bottom, okay? And that's, again, not because of how much the nail weighs or what the mass of the nail is, but it has to do with its density, okay? So just big picture, make sure when you're talking about something being lighter or heavier, right? Because the nail is lighter, it weighs less than the wood, but the nail is more dense, so it will sink. All right, hopefully that makes sense, okay? Okay, so let's say that this is sample 1 and this is sample 2, okay? And they each have 5 grams of material in there, all right? The mass is the same, but if I squish all these molecules together, okay, so these are very dense, they're all compacted together, and these guys in my sample 1 are all nice and spread out, okay? Maybe I should draw a border around it here. All right, so here's my sample 1, here's my sample 2, okay? If I went and weighed them on a scale, they're gonna weigh the same amount, right? This has 5 grams or 5 units, okay? This one also has 5 grams, 5 units, but their densities are different. This one is taking up a huge volume, okay? And this one is taking up a very teeny tiny volume. So this one's density is going to be more than this one's density, all right? Because there are more things compacted into a teeny tiny amount, all right? If I wanted to show this maybe, all right, you get the concept, all right? So if I added a lot more mass, okay, into this same container, now I have the same density as sample 1 to sample 2, right? They're gonna have the same density, so the same amount of stuff per volume that they take up. But if I put them on a scale, obviously sample 1 weighs a lot more, okay? So just make sure for big concept stuff, all right, that we understand that density is the mass of something divided by the volume it takes up. All right, so that's the concept.